you have a function defined on a region and it's the derivative of 0 everywhere in the region, then f has to be constant on that region. The idea behind the proof is if you take a region G, you take any 2 points in there, say Z1 and Z2, you can connect the points, since it is a region, you can connect the points by a series of horizontal and vertical lines, like so. And so we're going to prove that everywhere on this vertical line, the value is always f of z1. So the point here in particular is f of z1. But everywhere on here, we're going to prove is f of z1, f of z1, f of z1, f of z1. So in other words, f of z1 is going to equal f of z2. And since we did that for we can theoretically do this for every z1 and z2, that means that the function is going to equal a constant. Well, here's the basic idea. I'm just going to look at one of these vertical segments, and I'm going to prove that, let's call this v, I'm going to prove that the function's constant on the v. And so on this v, all the z's look like x naught plus iy. The only thing that's changing is the y. And so similarly, it's going to be useful to write down f of x plus iy equal to u of xy plus I v of xy. And notice that on v, I get u of x naught y plus I v of x naught y, which really means, right, these are just constants. So this is really equal to just u of y plus I v of y. So I really just have a function of one variable on this vertical stripe because there's only one variable there that's changing. So I can see what happens to both of these. Right? If I take the partial with respect to y here, since I'm going vertically, I want to see the partial with respect to y. Uy of y is going to equal, well, it's going to equal the real part of f prime of z, which has to equal 0. Similarly, v of y is going to have to equal the imaginary part of f prime of z, but that's equal to 0. So, but we already know that if you have, by the way, u of y and v of y, they're the only interesting ones, right? Because y is the only variable. So on this interval here, the only thing that's changing is the y. So we essentially have functions. These go from r to r, and their derivatives are 0. So if you just look at these functions of one variable, their derivatives are both 0, which means, by a previous theorem, if you have a function of real variables and the derivative is 0, then they have to be constant. Equals a constant 1 plus I times a constant 2. So on the horizontal strip, you get just a constant value. And the same reasoning goes for all the vertical ones, and very, very similar reasoning goes for the horizontal ones. So that's the basic idea. Is the setup is you pick any 2 points. It's simply connected so you can run through by just a whole bunch of kind of vertical and horizontal runs. And then you can just play this game by looking like, oh, this is really just a function of one variable. If you take the derivative, like u prime of y, which I can write as u of y, that's just going to give you the real part of f prime, which we know is 0. So this has to be constant. This has to be constant. So the whole thing is constant on v. And by similar argument, it's going to be constant on this h. Constant, constant, constant. The value never changes from z1 to z2. So these two have to be the same, so you get a constant value. And we're done.